Dear students, in JEE 2024 Phase 1, this question was from Electrostatic Potential and Capacitance. Question is, a 16 ohm wire is bent to form a square loop. A 9 volt battery with internal resistance 1 ohm is connected across one of its sides. If a 4 microfarad capacitor is connected across one of its diagonals, the energy stored by the capacitor will be x by 2 microjoule, where x equal to watt. Now see here in this question, a wire with 16 ohm resistance is given to you, and then it is bent to form a loop. And then after, a 9 volt battery with internal resistance 1 ohm is connected across one of its side. Then we connect 4 microfarad capacitor across one of its diagonal. And now we have to calculate the energy stored by the capacitor. So पहले फिगर में ये पूरा कनेक्शन समझ लेते हैं. तो देखो, here a wire with 16 ohm resistance that is bent to form a loop. Loop is prepared A, B, C, D, A. मतलब कि now each side that is with resistance 4 ohm. Then across one of its side, battery is connected. So here across AD, the battery is connected. So let's first calculate the current drawn from the battery, that is I. Now see here, this upper branch A, B, C, D have the total resistance 4 plus 4 plus 4, that is 12. And this branch AD have the resistance 4. And these 12 ohm and 4 ohm are parallel to each other. So, current drawn from the battery, that is the battery voltage upon total resistance of the circuit. So, total resistance, that is R1, R2 upon R1 plus R2, that is for this parallel combination, plus internal resistance of the battery. So voltage, that is 9, R1 resistance of this upper branch 12, and resistance of branch AD, that is 4. So 12 into 4 upon 12 plus 4 plus 1, and you will get the current, that is 9 by 4 ampere. Now when this current I reaches to A, it will be divided in two parts. I1, that is A to B, and I2, that is A to D. Through capacitor, current will not flow. So here current I1, that is R2 upon R1 plus R2 into I. ये हम थर्ड चैप्टर में पढ़ चुके हैं. Now see, R2, that is 4 upon R1 plus R2, that is 16 into current 9 by 4, that is 9 by 16 ampere. Now see here, A to B and B to C, total resistance is 8 ohm, through which current I1 is flowing. And now this capacitor is parallel to this 8 ohm resistance. Therefore, here voltage across capacitor, that is equal to voltage across ABC. So, voltage across ABC, that is current through ABC, that is I1 into resistance of ABC. I1 is 9 by 16 and resistance of branch ABC, that is 8. So, voltage across capacitor, that is 9 by 2 volt. Now, energy stored in the capacitor, that is half CV square. So, half C, that is 4 microfarad into voltage 9 by 2 whole square. So we'll get this is equal to 81 by 2 microjoule. Here in question it is given x by 2 microjoule. So if we compare these two, then we will get x that is equal to 81. It implies our answer that is 81. Clear to all of you?